A very fresh good morning to all of you. Here I have come up with my new video on the new topic. But before that, don't forget to like and subscribe my channel, and for any problem or query, please write down in comment box. Yesterday we have discussed about one of the method known as simple distillation, which is used to separate the mixture of two miscible liquids having different boiling points. The liquid having lower boiling point distills over first, and the liquid having higher boiling point distills later. Basically, the principle of this method is difference in the boiling point. It should be at least 25 degrees Celsius or more than that. You can see from the example, here we are having the mixture of acetone and water, in which the boiling point of acetone is 56 degrees Celsius and that of water is 100 degrees Celsius. The acetone will start vaporizing first and then condenses and separated in separate flask, and water is left behind in the round bottom flask. By this method, we can easily separate the mixture of liquids, miscible liquids, which are having the difference in boiling point more than 25 degrees Celsius. But sometimes the liquid contains some amount of other liquid, so we can say that complete separation of two miscible liquids cannot be done by simple distillation. For the complete separation of two miscible liquids, the process of distillation is used. So today we are going to start with the new topic, that is fractional distillation. The fractional distillation is the process of separating two miscible liquids. The separation of these two liquids by fractional distillation depending upon the difference in their boiling point. If two miscible liquids have the difference in the boiling point less than 25 Kelvin, then the technique of fractional distillation is used to separate them. If the difference is more than 25 Kelvin, then simple distillation technique can also be used, that we have discussed yesterday. In this method of fractional distillation, there is a difference in the arrangement of the apparatus. In this fractional distillation, we use the fractional column, which we are not using in simple distillation process. This fractionating column is a long vertical glass tube, as you can see from the diagram, in which glass beads are filled. These glass beads are providing large surface area for the hot vapors which are coming from the round bottom flask. As these hot vapors will start accumulating in the fractionating column, they start getting cooled down and condense repeatedly. The upper part of the fractionating column is cooler, so the hot vapors rises up in this column, get cooled down, condense and move back into the distilled flask. Let us understand the separation of two miscible liquids with the help of upcoming video.
Fractional distillation. When the boiling points of the two liquids are very close, then simple distillation does not work. In that case, a fractionating column is used, which is long tube provides obstructions to the passage of the vapors upwards and to the passage of liquid downwards. The mixture of liquids A and B with 370 Kelvin and 380 Kelvin boiling points respectively is present in the flask. On heating the flask, the vapors obtained are more of A and less of B. As the vapors rise up in the fractionating column, the partially condensed liquid flows down. The vapors of B condense faster as compared to A, and the vapors moving up richer in A. The condensed liquid flowing down strikes the vapor and it consumes molecules of B. This process is repeated throughout the fractionating column, due to which the vapors escaping through the top of the column are almost of A and the liquid left in the flask almost of B.
Now, Fractional distillation separates the various liquids according to their boiling points. The more volatile means having less boiling point distills first, and the liquid having higher boiling point distills later. Now, let us understand how the technique of fractional distillation is used to separate the different gases of air. We know that air is a mixture of gas like nitrogen, oxygen, argon, carbon dioxide, etc. The major component of air is nitrogen, that is 78%. The second major component of air is oxygen, that is 21% approximately, and the third is argon, approximately 10%. All the remaining gases of air constitute only 0.05% of air. As we know that different gases are having different uses in our day-to-day life, like nitrogen can be used for making fertilizers, oxygen can be used for making steel in the factories, in hospitals even for breathing difficulties. Argon can be used to fill in the electric bulbs. So it's necessary to obtain these different gases from air on a large scale. Now, the method which we are using here to separate these gases from air is fractional distillation again. Let us have a look on the video.
Separation of components in air. Air is a mixture of several gases, and these can be separated by fractional distillation. This is brought about by compressing and cooling of air and allowing it to slowly warm up in a fractionating column. Air is first passed through a filter to remove impurities like dust particles. Filtered air is passed through compressors and it is compressed to very high pressures around 200 atmospheres. Compressed air is passed through a freezing unit where it is cooled to about -200 degrees centigrade. The cooled and compressed air passes through a separator when carbon dioxide gas solidifies and is separated as dry ice. The air which is now free from carbon dioxide is forced through an expansion jet where it liquefies. This liquid air is allowed to slowly warm up in a fractionating column. Nitrogen first boils at -196 degrees centigrade and is separated. The argon, which boils at -186 degrees centigrade, is collected. Oxygen, which has a higher boiling point, is left behind and is collected separately.
The next we are having day-to-day application of the process of fractional distillation. The first application, it is used to separate the mixture of miscible liquids like we have done about alcohol and water, acetone and water in the laboratories. It is also used to separate the different amount of gases from the air as we have done from the activity. The third very important, which you have done in the 8th class also in the chapter coal and petroleum, that is, it is used to separate crude oil petroleum into useful fractions such as kerosene, diesel, residue, fuel oil, petrol, etc. As you can see from the arrangement that the crude oil is heated at very higher temperature. The substances which are achieving their boiling point, they start separating one by one and start moving out of the arrangement of separating or fractionating tower. The next we are having how this technique of fractional distillation is different from simple distillation process. Simple distillation is used when the miscible liquids having a very large difference in their boiling point. But if the difference in their boiling point is less than 25 Kelvin, then fractional distillation process is used. In simple distillation, a simple apparatus is used, that is 2 flasks, 1 condenser, thermometer, etc. But in case of fractional distillation, an apparatus fractionating column is used, which is made up of large glass tube having glass beads in it to increase the surface area so that hot vapors will start condensing repeatedly. I hope you have understood today's topic, that is fractional distillation, about its application and how it is different from simple distillation process. Please go through these questions given in assignment, and for further query please write down in comment box. Thank you and have a nice day.